About 1 in every 9 people in the world lack access to clean and safe water. 80% of illness in developing countries is due to water and sanitization issues. In order to have available water, children often have to sacrifice their education and travel miles to gather water full of harmful pollutants and bacteria. This is a huge health risk to these communities, causing many illnesses. There is currently a lack of infrastructure or resources to put in water purifying plants.
Water security is a problem that few of us are ever forced to think about. Yet, according to the UN, around 700 million people worldwide do not have a dependable source of clean water.
A solution must be created to provide safe and accessible water while remaining low cost, low infrastructure, and efficient as possible. UV water purification is a proven form of killing harmful pathogens with the germicidal properties of natural UV light from the sun.
Introducing the solution system. Solar ultraviolet purifier enhancing radiation, active in daylight system. The system begins with an input funnel at the height of the system that will be manually filled by users. The funnel is accompanied with a tight wire mesh right before the pipe entrance, acting as the primary large solids filter. This ensures that larger dirt and rock material is separated at the very beginning of the system to avoid damage and contamination. The height of the input will also allow gravity to move water through the multi-step filtration system without the need for additional energy input. The water is controlled by a valve that will allow the water to enter the soda's bed. Before entering the bed, the water is pushed through a series of 2 water sediment filters with micron filters. The purpose of this filter is to utilize the environmentally friendly and cleansing properties of glass sand, activated charcoal, and other small solids found in the natural environment to catch and destroy remaining solids and harmful bacteria and microorganisms immune to UV radiation.
The filters are accessible for routine cleaning and maintenance through an analog access hatch on the galvanized steel pipe. This bed is made from black polyethylene to increase the absorption of heat. The bed is covered by a borosilicate glass cover that allows 90% of UVA and 45% of UVB light to pass through. Borosilicate glass is durable in many different climates, allowing for the widespread implementation of our system. Depending on the UV conditions of a given day, after the water is sat for its respective 6 to 24 hours, the second valve can be opened to allow water to flow into the holding tank, which can hold 2,000 liters of clean drinking water. At this point, a new batch of water can begin processing in the bed and clean water may be received from the tank. Although simple in design, the system was designed to be an ecologically friendly water purification system, accessible to all communities, regardless of their access to electricity and other privileges.
Solar disinfection is a commonly used, cheap, and effective method of removing microbiological life from drinking water. When water is collected and exposed to sunlight for extended periods of time, much of the bacterial life is going to die off. And this works in 2 ways. The first is the ultraviolet radiation coming from the sun, and it's very effective at disabling bacteria and other pathogens. And this is because UV radiation has a very small wavelength that's very high energy. It's easily able to pass through the cell membrane and can directly interact with DNA, resulting in damage. After prolonged exposure, this can result in the cell dying. According to the World Health Organization, a temperature of about 65 degrees or above is going to completely kill the bacteria. And as the water heats up, it's going to become progressively more difficult for bacteria to survive the rising temperatures.
How logical is the implementation of our system as compared to traditional purification plants that can cost millions of dollars to build and maintain? Our system can support communities of 100 to 200 people even at its lowest efficiency. We think on a bigger scale so the system can positively impact as many people as possible. While the solution may be simple, it can provide communities with access to one of their most basic needs. This system was made ideally for villages with populations of a few hundred people in Africa, where it is often very sunny with high temperatures. The ideal area is between 35 north and south latitude. This means areas such as Chad and Ethiopia in Africa could especially benefit from our system. Another important point to note about our system is it takes very little maintenance, further reducing the costs. We hope to continue to maximize and test our system to maximize the implementation areas. For further information on the design process and specifications of our product, see our technical report. Thank you so much for taking the time to listen to our solution and helping to better our world.